Good morning, ladies and gentlemen. How are you going today? All right. So today we're going to go back and looking at our proofs topic because we need to cover all of Unit 1 because our exam is quite possibly somewhere around week 7. But that's okay. We'll get it done. You might hear some background noise as well because there's construction going on in C Block. They're putting solar panels on the top of C Block. Right, so recapping so far, so at the end of term 1, we started looking at mathematical statements. So this is just recap. We looked at statements which had like there exist, and then statements which involved for all reals and for all x values in the reals. And we saw that using De Morgan's laws, such as the opposite or not A or B is not A and not B. So that's the negation of the or statement. And if you had the negation of not A and B, then that was not A or not B. And then we gave examples using like, would you like milk or sugar in your tea or coffee? So the opposite of or is and the opposite of and is or. We also looked at the end of term 1, this thing called an if-then statement, like implications. So the symbol for that was P implies Q, or if P happens, then Q happens as a consequence. So if X is 5, then X squared must be 25. We also saw that not the negation of if P then Q is P and not Q, so that was the opposite of if P happens then Q happens. We also looked at this thing called a converse statement, so you just flip the if P then Q around to P implies Q, which may not be a true statement, right? So if P then Q is true, if X equals 5, then X squared is 25, the converse, X squared equals 25, then X equals 5 may not be true because X could also be negative 5. So, but it's just a way of saying the mathematical statement. So Q implies P. We also said that a statement is equivalent if P implies Q and Q implies P, and that was written with double arrows, and we say that P if and only if Q. So what that means is if P happens, then Q is true, and equivalently, if Q happens, then P is true. So that's the if and only if statement. So today we're going to start looking at ways of proving mathematical statements. So it's just like arguing, but with evidence, with good solid evidence, right? So one of the easiest way of proofs is proof by counterexample or disproof by example. So what that is saying is all you need is one example to show that a statement is false. But one example can not prove a statement to be true. So one example can prove a statement to be false, but one example can not prove a statement to be true. And then later on, we'll see different techniques to prove a statement to be true. So to show something's false, you just need to give me a counterexample why the statement is false. So in particular, if we're trying to prove an if-then statement, so you're trying to prove an if P then Q is false, then find an example where P is true, so P happens, but Q does not happen. So to prove if P then Q is false, show that if P is true, then Q is false, and that statement cannot occur. So let's have a look at example 5. It says, find a counterexample to disprove, so to show that the statement all prime numbers are odds is false. Well, okay, well, think about it. They're claiming here that every single prime number in our number system are odd. Well, is that true or not? Well, that statement is false. Why? Can you give me an example where a number is prime but it's not odd? So is there an even prime number? Well, yes, because 2 is our smallest prime number. 2 is prime and 2 is even. So therefore, not all prime numbers are odd numbers, and we've proved the conjecture, that statement, to be false by using a counterexample. So in terms of writing down our evidence, we would say that, well, 2 is a prime number. Number, can't spell. And 2 is even, in other words, not odd. So therefore, not all prime numbers are odd numbers. Can't spell, come on. Odd numbers. Therefore, conjecture is false. So you just need one example, one counterexample to show that a statement is false. But very importantly, you cannot prove a statement is true just because of one example. You need to show it's true for every